Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Interface Python with SQL, Part 1, Introduction, Errors in Python and Debugging, Syntax Error. Runtime Error, Logical Error, what is exception handling? With practical implementation, for the class 12 students of Computer Science. So, let's dive in and get started. Besides the computer programs we develop, exceptions, errors, or unusual circumstances can also arise in our everyday experiences. Let's consider a real-life scenario. You leave your house for a picnic by car. On the way, the tire bursts and you are forced to stop the car and replace the tire. In this scenario, the punctured tire is the exception that has occurred unexpectedly. In such a situation, we are required to carry along a spare tire, so that we can change the punctured tire then and there and continue with our journey. This concept is similar to exception handling in computer programming. Many times, when people write code for making applications, they make errors in it. So, when your app suddenly stops working out of the blue, it's usually because of one of these mistakes or errors. But, we all know that fixing these errors is just something we have to do when we're making apps. The process of finding errors in a program is termed as debugging. Errors in a program can cause it to not work properly or give incorrect results. That's why it's important to identify and fix these errors to ensure the program runs correctly. Errors in Python are classified mainly into three types: syntax error, runtime error, logical error. Syntax means the arrangement of letters and symbols in code. So if you get a syntax error, it usually means you've misplaced a symbol or letter somewhere in your code. Python will usually tell you which line and where in the line the problem is. It is completely normal for beginners to make syntax errors all the time. The only thing that helps is practice. What is a syntax error? A syntax error is an error in the syntax of a sequence of characters or tokens that is intended to be written in a particular programming language. Syntax errors occur when the structure of code violates the rules of a programming language. Syntax errors are the most common types of errors and are easily traceable. They occur while the statement is being translated to machine language and before being executed. Example: incorrect indentation, misspelling a keyword. Learning out a symbol such as colon, comma, or parentheses. They can be corrected by the user as the reason for the error and an appropriate message about what is wrong in the program is displayed. Let's see some examples. One of the syntax error is incorrect indentation. What is indentation? Indentation in programming refers to the spaces or tabs placed at the beginning of a line of code to visually represent the structure or hierarchy of the code. In many programming languages, including Python, indentation is not just a matter of style but is syntactically significant. What is incorrect indentation? Now look at this example. In this example, the print statement is incorrectly indented. That is without spaces, white spaces. In Python, the standard convention for indentation is to use 4 spaces for each level of indentation. In Python, indentation is crucial for defining the structure of code blocks, such as functions, loops, and conditional statements. Below you can see the correct indentation of the print statement. So we can correct the syntax error when the errors are displayed. Next syntax error is misspelling a keyword. In this example, the keyword while is misspelled as while. Python is case sensitive, so even a small typo like this can lead to a syntax error. Below you can see while spelled correctly. Next syntax error is missing colon. In this example, the colon is missing at the end of the if statement. It's a syntax error. Colons are used to denote the beginning of an indented code block for constructs like if, for, while, and function definitions. Below you can see the colon included. Next syntax error is missing comma. In this example, commas are missing between the elements of the list, 1, 2, 3, 4, 5. Below, you can see the commas included between elements of the list. Next syntax error is missing parentheses. In this example, the closing parenthesis is missing at the end of the print statement. All open parentheses must be matched with a closing parenthesis in Python. You can see the closing parentheses done and the output scene is Hello World. These are common mistakes that can result in syntax errors in Python code. Always double-check your code for these kinds of errors, and pay attention to error messages provided by Python, as they often indicate the location and nature of the syntax problem. In Python, print function is a built-in function used to display output. It's important to note that Python is case-sensitive, so print function with lowercase p is the correct syntax, while print function with uppercase p would result in a syntax error. So when print function with lowercase p is typed, it prints welcome to Sally and Bytes. Next error in Python is the runtime error. A runtime error in Python refers to an error that occurs during program execution rather than during compilation, indicating an issue that prevents the program from running correctly. That means, a runtime error occurs after Python interpreter interprets the code you write and the computer begins to execute it. Runtime errors come in different types and some are hard to find. Errors are exceptional, unusual, and unexpected situations and they are never part of the normal flow of a program. You know, you have a runtime error when the application suddenly stops running and displays an error, exception, dialog box or when the user complains about erroneous output. It usually results in abnormal program termination during execution. Note: Python is an interpreted language, which means that Python code is executed line by an interpreter without the need for a separate compilation step. The Python interpreter translates the code into machine code at runtime, executing it immediately. This is why Python runtime errors occur during program execution rather than during a separate compilation phase. In Python, such unusual situations are termed as exceptions. Exceptions are usually runtime errors. Let's see some examples of runtime error. Division by 0. Look at the yellow box. Result equals 10/0. This will raise a zero division error because dividing by 0 is not allowed in arithmetic operations. Zero division error is a built-in Python exception that occurs when attempting to divide a number by 0. This error typically happens when you attempt to perform division where the divisor, the number you're dividing by, is 0, which is mathematically undefined. Next runtime error. Performing an operation on incompatible types. Look at the yellow box. The statement result equals hello plus 5 attempts to concatenate a string, hello, with an integer, 5. However, in Python, concatenating a string with a non-string, such as an integer, using the plus operator raises a type error. In Python, the plus operator is used for both addition, when applied to numbers, and concatenation, when applied to strings. When you use plus with a string and another non-string type, Python expects both operands to be strings to perform concatenation. If one of the operands is not a string, Python doesn't know how to concatenate them, hence raising a type error. Next runtime error. Using an undefined identifier. Look at the yellow box. In the statement print, undefined underscore variable, you're attempting to print the value of a variable named undefined underscore variable. However, if undefined underscore variable has not been previously defined or assigned a value in the code, Python will raise a name error. A name error occurs when you try to use a variable or identifier that hasn't been defined in the current scope or namespace. Python requires that variables be defined before they are used, either by assigning them a value or declaring them as part of the program's structure. Next runtime error. Accessing list elements. Look at the yellow box. In the statement my_list equals list containing elements 1, 2, 3, you're creating a list named my_list containing 3 elements, 1, 2, and 3. Lists in Python are zero-indexed, meaning the index of the first element is 0, the second element is 1, and so on. However, in the subsequent statement print, my_list of 3, you're attempting to access the element at index 3 of the list my_list. Since lists are zero-indexed and my_list contains only 3 elements, the valid indices for my_list are 0, 1, and 2. Therefore, trying to access my_list 3 is beyond the bounds of the list and will result in an index error. Next, runtime error. Accessing dictionary values. Now, look at the yellow box. In the statement, look at the first line. You're creating a dictionary named my_dict with 2 key value pairs, A:1 and B:2. Dictionaries in Python are collections of key value pairs, where each key must be unique. However, in the subsequent statement print of my_dict is C, you're trying to access the value associated with the key C in the dictionary my_dict. Since the key C does not exist in the dictionary my_dict, attempting to access it will result in a key error. Next, runtime error. Accessing object attributes that don't exist. Look at the yellow box. Here, we define a class myClass with a constructor __init___ method that initializes an instance variable attribute with the value 42 for any instance created from this class. Then, we create an object of type myClass using the constructor myClass function. This object has an attribute named attribute initialized to 42. However, in the subsequent line print, obj.nonexistent_attribute, we're attempting to access an attribute named nonexistent_attribute of the object obj. Since nonexistent_attribute was never defined for instances of myClass, attempting to access it will result in an attribute error. So how should the code be to print the value 42? We access the existing attribute of the object obj and print its value. This will correctly print 42 without raising any attribute error because attribute is defined for instances of myClass. You can see the corrected code on the right side highlighted in blue color. Corrections done for the previous example and it outputs the value 42. Next, runtime error, trying to access a file that doesn't exist. Look at the yellow box. Here we're attempting to open a file named nonexistent_file.txt in read mode, R, using a with statement. This with statement is commonly used in Python for handling files because it automatically closes the file after the block of code inside it is executed. However, if the file nonexistent_file.txt does not exist in the specified location, Python will raise a file not found error when attempting to open it. This exception occurs when Python tries to access a file that doesn't exist in the file system. Let's learn about logical errors. A logical error in programming, also known as a bug, called semantic error, occurs in Python when the code runs without any syntax or runtime errors but produces incorrect results due to flawed logic in the code. These types of errors are often caused by incorrect assumptions, an incomplete understanding of the problem, or the incorrect use of algorithms or formulas. Identifying and fixing logical errors can be challenging because the code may run without raising any errors, making it harder to pinpoint the issue. The error is caused by a mistake in the program's logic. You won't get an error message because no syntax or runtime error has occurred. Debugging techniques such as code inspection, printing intermediate values, and using a debugger are often employed to locate and rectify logical errors. Let's see some examples of logical errors. Using the wrong variable name for calculations. Look at the yellow box. The mistake here is that the variable pi is used without being defined anywhere in the code. It seems like the intention is to use the mathematical constant pi to calculate the area of the circle. However, in Python, the constant pi is not built in, you need to import it from the math module. The correct way to use the pi constant is by importing it from the math module and referencing it as math.pi. So, the corrected version of the code would be, you can see on the right side of the screen, highlighted in yellow color. Import math, radius equals 5. Area equals math.pi star radius raised to the power 2. Print the area of the circle, area. Next logical error. Using integer division instead of the division operator. The intention here is to calculate the average speed in miles per hour, mph, by dividing the distance in miles by the time in hours. However, the code uses the integer division operator, // instead of the regular division operator, /. Integer division returns the quotient of the division, discarding any fractional part, so the result will always be an integer rounded down towards -infinity if necessary. Using integer division in this context is incorrect because it rounds down the result to the nearest integer, which does not accurately represent the average speed in mph. Instead, the regular division operator should be used to get the correct average speed with decimal precision. Next logical error. Using modulus operator instead of the division operator. The intention here is to calculate the total number of pages required to display all the items, given the total number of items, total_items, and the number of items per page, items_per_ page. However, the code uses the modulus operator, %, instead of the regular division operator, /. The modulus operator returns the remainder of the division operation, not the quotient, which makes it unsuitable for calculating the total number of pages. However, using the modulus operator in this context is incorrect because it provides the remainder of the division operation, not the total number of pages required. Instead, the regular division operator, /, should be used to get the correct total number of pages. Next logical error. Giving wrong operator precedence. Look at the blue box. In this example, the code intends to calculate the result of adding 5 to the product of 3 and 2. However, due to incorrect operator precedence, the multiplication, 3 multiplied by 2, is evaluated first before the addition, 5+. As a result, the multiplication is performed before the addition, and the result becomes 5 plus 6, which equals 11. To fix this error, parentheses should be used to enforce the correct order of operations. Now, look at the yellow box. With the corrected precedence, the addition, 5 plus 3, is performed first, which is enclosed in brackets, Bodmer's rule, brackets first, resulting in 8, and then the multiplication, 8 multiplied by 2, is performed, resulting in the correct answer, which is 16. What is the meaning of exception? An exception is an unexpected problem that can occur while a computer program is running. An exception is like a surprise problem that happens when you're playing a game or doing something fun on the computer. Imagine you're playing a game and suddenly your character gets stuck in a place it's not supposed to be. That's an exception. It's like a little bug in the game that makes something unexpected happen. But don't worry. Just like how you ask a grown-up for help when you're stuck in a game, programmers have ways to fix these surprises in their computer programs too. They use special tricks called exception handling to catch these surprises and make sure the game keeps running smoothly. Now, what is exception handling? Exception handling is the process of managing and dealing with unexpected problems or errors that arise during the execution of a computer program to prevent crashes and ensure smooth operation. An exception can be described as an interrupt or an event triggered during the normal flow of the execution of a program, which is to be handled carefully. Now listen. It's a situation where something unexpected happens that disrupts the regular flow of the program. This interruption could arise due to various reasons such as invalid user input, hardware malfunctions, network issues, or even logical errors within the program itself. Come to the blue point. When an exception is raised on account of some error, the program must contain code to catch this exception and handle it properly. Let me explain. Imagine you're following a recipe to bake a cake. Suddenly, you realize you're out of eggs. This is like an exception, something unexpected happened that could mess up your cake. So, what do? You handle it. You might have a plan for when things go wrong. Maybe you remember you can use applesauce as an egg substitute. That's your way of catching the problem and solving it. In programming, it's the same idea. When something unexpected happens, like dividing by zero or trying to open a file that doesn't exist, the program raises an exception. Your code needs to be ready to catch these exceptions and deal with them gracefully. It's all about being prepared for surprises and making sure your program can keep running smoothly, just like making sure your cake turns out okay even if you're out of eggs. Exceptions are often used with network and file operations. Important terms related to exception handling. Traceback. Let me explain. Think of traceback like a map that shows the path your program took before it got stuck because of an error. Imagine you're following a trail in the woods, and suddenly you hit a big tree blocking your way. The traceback is like a map that helps you trace back the steps you took before you reached that tree. It tells you which paths you followed, where you turned, and how you ended up at the tree. In programming, when there's an error, the traceback shows the steps the program took before it ran into the problem. It tells the programmer which parts of the code were running, where the error happened, and what functions were involved. This helps programmers figure out what went wrong and how to fix it. Now come to the point. When an exception occurs in a program, the traceback is a detailed report that shows the sequence of function calls leading up to the point where the exception was raised. It provides information about the file names, line numbers, and specific functions involved in the execution path, helping developers diagnose and troubleshoot errors. Next is try block. Let me explain. Imagine you're building a sandcastle on the beach, but you know that sometimes big waves can come and knock it down. The try block is like putting a protective barrier around your sandcastle. It's a special area where you know things might go wrong, so you're ready for it. You put all the important parts of your sandcastle inside this protected area. Now, if a big wave, an exception, comes and hits your sandcastle, your code, the try block acts like a shield. It tries to catch the problem before it causes too much damage. If something goes wrong inside the try block, instead of crashing your whole program, the try block helps keep things under control. So, in simple terms, a try block is like a safety net for your code. It's where you put the parts of your program that might have problems, so if anything goes wrong, you can handle it without everything falling apart. Now come to the point. A try block is a section of code where potential exceptions are anticipated and monitored. It encloses the code that might raise an exception. If an exception occurs within the try block, the program attempts to handle it according to the associated catch blocks. Except block or catch block. Let me explain. Let's imagine you're playing a game where you're trying to catch different types of animals. Sometimes you might catch a bird, sometimes a fish, and sometimes a rabbit. Now, when you catch each of these animals, you want to handle them differently, right? The except block is like having special cages for each type of animal you catch. When you catch a bird, you put it in the bird cage. When you catch a fish, you put it in the fish tank. And when you catch a rabbit, you put it in the rabbit hutch. Similarly, in programming, the except block is where you handle different types of problems that might occur in your code. Each except block is like a cage that's designed to catch a specific type of problem or exception that could happen in your program. For example, you might have one except block to catch errors related to not finding a file, another for dividing by zero, and so on. So, when a problem happens inside the try block, the program looks at all the except blocks to see if there's one that matches the type of problem. If it finds a match, it knows how to handle that specific problem using the code inside that except block. It's like having a plan for each type of problem your program might encounter, so you can deal with them in the best way possible. Now come to the point. An except block, or catch block in some languages, is used to catch and handle specific types of exceptions that occur within the corresponding try block. Each except block typically specifies the type of exception it can handle and contains code to respond to the exception appropriately. Let's imagine you're playing a game of hot potato. The goal is to pass the potato around, but if someone drops it, they have to shout "oops" and throw it to someone else. In programming, when something unexpected happens in your code, you can use a throw block, or raise block in some languages, to shout "oops" and pass the problem to another part of your program. Here's how it works. Imagine you're writing a program to count apples, but suddenly you find a rotten one. Instead of dealing with the rotten apple right where you found it, you throw it, or raise it, to a different part of your program that knows how to handle rotten apples. So, when you encounter a problem in your code and you want to make sure it's handled properly, you use a throw or raise statement. This tells the program that something unexpected happened, and it needs to pass the problem to another part of the code that knows how to deal with it. Then, like passing the hot potato, the problem gets passed up through the different parts of your program until it reaches a place where it can be handled, like an except block we talked about earlier. This helps keep your program organized and ensures that problems are dealt with in the right way. Now come to the point. The throw block, or raise block in some languages, is used to explicitly raise an exception at a particular point in the code. When a throw or raise statement is encountered, the specified exception is generated and propagated up the call stack until it is caught and handled by an appropriate except block. Unhandled, uncaught, exception. Let me explain. Imagine you're playing a game of Pass the Parcel, where everyone sits in a circle and passes a parcel around while music plays. When the music stops, whoever is holding the parcel unwraps one layer. Now, imagine if the parcel is accidentally dropped by someone, and nobody catches it. The parcel hitting the ground represents an unhandled exception. In programming, it's like having a problem occur in your code, but you haven't written any instructions on what to do if that problem happens. So, when an unhandled exception occurs in a program, it's like dropping the parcel and not knowing what to do next. The program doesn't have any instructions on how to deal with the problem, so it can't continue running smoothly. In most cases, the program will stop running altogether, and an error message or traceback will appear, showing where the problem occurred and why. This helps the programmer understand what went wrong so they can fix it. Now come to the point. An unhandled exception refers to an exception that is not caught and handled by any except block within the program. If an exception remains unhandled, it typically results in the termination of the program and may produce an error message or traceback indicating the cause of the exception. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos, Exception Handling, Part 2. Standard exceptions in Python, common Python exceptions. With practical implementation. You can check the link in the description box given below.